Ever tried learning from a textbook, like just totally riddled with errors?
Oh, yeah.
Frustrating.
Super frustrating.
Well, that's kind of the daily grind for large language models.
Yeah,
You know, those AI systems designed to kind of write and think like us.
right.
Today, we're diving into some research that tackles this whole problem head on.
Okay.
It's called ROBUSTFT.
Interesting.
Yeah.
I like that textbook analogy.
Yeah,
It's
yeah.
really spot on. And, the implications are huge.
Oh, yeah.
We're talking about, AI making decisions in healthcare,
Oh, absolutely.
finance, really, you name it.
Jenny.
If the data that it's trained on is flawed,
Yeah.
the consequences, they could be disastrous.
We've got the paper right here in front of us.
Great.
Robust FT.
Yeah.
Robust supervised fine-tuning for large language models under noisy response.
Okay.
Now, full disclosure, this gets pretty
Yeah.
technical,
I think.
but I'm curious, before we even break it down, like how big of a problem is this noisy data?
Well, the study showed that even just a little noise, like around 30%,
Okay.
can make an LLM almost 9% worse at complex tasks.
Wow.
And that's just the tip of the iceberg, really. As noise increases, the performance just tanks.
So it's not just about the AI being a bit off. It could make significant errors
Yeah.
with real brain impact.
Real world impact, absolutely.
Yeah, this is
Which is why,
disgusting stuff.
yeah, this is why this robust FFT solution is so intriguing.
Okay.
Um, Imagine like a two-step cleaning process, but for your data,
Okay.
making it much more reliable for training the AI.
I'm picturing like a team of like super powered editors
Yeah.
combing through every line. Like, is that kind of
You
close?
have the right idea.
Okay.
The first stage is noise detection.
Okay.
So multiple expert LLMs, think of them as your editors.
Okay.
They analyze the data, and they're looking for inconsistencies.
So instead of just relying on one AI, they're using a whole team to cross-reference.
Exactly. And they don't just skim the surface.
Yeah.
They use a reasoning-enhanced process.
Okay.
Meaning they look at the logic and context, like a human would when they spot a suspicious claim.
Got it.
And then there's a checker,
Okay.
which compares their findings to the original data,
Okay.
flagging anything that doesn't add up.
I'm already impressed.
Yeah.
And that's just step one.
This is just the first step.
Yeah, what happens once these expert LLMs have identified the noise?
Well, then comes data denoising,
Okay.
which is where things get really clever.
Okay.
It starts with context-enhanced relabeling.
Right.
Imagine using the good parts of the data
Okay.
to fix the bad parts.
So like using like a trusted dictionary to fix typos,
You got it.
but on a much grander scale.
You got it.
Got it.
And to ensure accuracy, a review agent steps in.
Okay.
Think of it as the most meticulous editor, like scrutinizing the revised information to make sure it's top-notch.
Wow, with all this checking and refining,
Right.
how do they ensure only the highest quality data makes it through for training?
Right. So that's where the data selection stage comes in.
Okay.
Only data that passes a rigorous quality check based on confidence scores gets the green light.
It sounds incredibly thorough, but why should someone who isn't like an AI researcher care about all this? Like, what's the big takeaway?
It boils down to trust. Really,
Okay.
robust FT could be the difference between, an AI that makes dangerous medical misdiagnoses
Right.
and one that saves lives.
Yeah.
It's about making sure the AI we rely on is built on a solid foundation of reliable data.
That's a powerful way to put it.
Yeah.
So we've gone from messy data to this robust, cleaned up version.
Right.
What impact does that actually have on the LLMs themselves?
Well, the results were significant.
Okay.
Robust FT consistently improved performance across various LLMs and data sets, even with very high levels of noise.
So you're telling me this isn't just some theoretical improvement.
No.
They saw like real tangible results.
Absolutely.
That's amazing.
And what's really interesting is that, the researchers discovered some surprising things along the way.
Okay, like what?
Well, for instance, you might assume that larger, more complex LLMs would be better at handling noisy data.
Yeah, I would thought
Yeah.
a more complex system could filter out the noise more easily.
Well, it turns out that larger LLMs need even more data to be trained effectively.
Okay.
And that just increases the chances of encountering errors.
Right. Right.
Robust training is just as crucial for these large models, maybe even more so.
So it's like having a bigger engine,
Yeah,
but it needs higher quality fuel to run smoothly.
a perfect analogy.
Okay.
And it highlights another important finding.
Okay.
The specific task an LLM is trained for matters a lot too.
Okay, so
LLMs built for general purposes might struggle with specialized tasks.
it's like expecting a general practitioner to perform brain surgery.
Exactly.
Got it.
RobustFT helps LLMs adapt and perform better in these specialized fields,
Okay.
even with all the messy data that comes with them.
Yeah.
It's like giving an LLM specialized training, like sending it to grad school for a specific field.
Okay.
You know?
This robust FT is starting to sound less like a technical paper
Yeah.
and more like a training regimen for AI.
Yes, a little bit.
There's one more part I want to understand better.
Okay.
The ablation study.
Right.
That sounds intimidatingly technical.
It's a scary word, but it's not as complicated as it sounds.
Okay.
Think of it like taking apart a complex machine to see which parts are essential.
Okay.
So that's what the researchers did with RobustFT.
Yeah.
They tested each step of the process to see its individual impact.
So they were basically playing AI Jenga,
Uh,
pulling out pieces to see if the whole thing would collapse.
that's a fun way to think about it.
Okay.
And the results were pretty definitive.
Okay.
Every stage, from the initial noise detection to the final data selection,
Yeah.
played a crucial role in handling that noisy data.
Okay.
Removing even one part, significantly reduced the effectiveness of the system as a whole.
That's impressive.
Yeah.
It really shows the depth and effectiveness of their approach. It's
Yeah.
not just a random collection of tricks.
Right.
It's a carefully designed system
Yeah.
where each part is essential.
Precisely. And this level of rigorous testing gets us confidence in the findings of the study.
Right.
And the potential of RobustFT to make a real difference in the world of AI.
Wow.
But the implications go far beyond the technical.
Yeah.
It's about building AI we can truly rely on.
That's huge.
Yeah. It's like they built AI with like a built-in BS detector.
Yeah.
Which is more important now than ever as AI gets involved in fields like healthcare.
You're right. The stakes they're getting higher and higher.
Yeah.
And this idea of robust FT, this feels like it has implications beyond just like tweaking algorithms, right?
Absolutely. Think about it.
Yeah.
We're on the cusp of using AI to analyze medical records,
Oh, wow.
make financial predictions,
Yeah.
even filter the information we see online.
It's everywhere.
If that AI is trained on bad data,
Yeah.
well, it's a recipe for disaster.
So robust FT isn't just some technical tweak.
No,
It's fundamental to building AI we can actually trust.
exactly. It's about ensuring that the AI we're putting so much faith in
Right.
is making decisions based on the most accurate information possible.
It makes you wonder if this kind of noise handling could be applied beyond just LLMs. What other areas could benefit from this type of approach?
That's where it gets really interesting.
Okay.
Imagine applying these principles to things like analyzing climate data,
Okay.
predicting traffic patterns,
Yeah.
or even personalizing education. Any field where data quality is crucial could potentially benefit from a robust NFT approach.
It's almost like this research is like a blueprint for building more resilient systems.
Yeah.
Systems that can learn and adapt even when the information they're fed is less than perfect.
And that has huge implications for the future of AI.
Oh, yeah.
Imagine AI that can just sift through, the mountains of data we generate every day
It's so much data.
and extract meaningful insights,
Right.
even when that data is messy and incomplete.
That's a powerful thought.
Yeah.
It feels like we're moving from this idea of AI as like a perfect all-knowing system
Right.
to something more human, something that can navigate the complexities and imperfections of the real world.
And that's what makes RobustFT so exciting.
Yeah.
It's not just about making AI technically better. It's about making it more aligned with the way we as humans actually operate in the world.
Right.
We're constantly dealing with incomplete information.
Yeah, we are.
Making decisions based on imperfect data.
All the time.
Now we're starting to build AI that can do the same.
So instead of trying to create perfect AI,
Yeah.
we're teaching it to embrace the mess.
In a way, yes.
Oh, yeah.
It's about acknowledging that perfect data is a myth,
Right.
and instead focusing on building AI that can thrive in the real world
Yeah.
with all its inherent noise and complexity.
This whole conversation has really shifted my perspective on AI.
Yeah.
It's less about striving for some unattainable ideal
Right.
and more about embracing the messy reality we all live in.
Absolutely.
But before we get too philosophical,
Yeah.
there was one thing in the paper I wanted to circle back to.
Yeah.
The researchers found that robust FFT wasn't just about cleaning up data.
Right.
It actually had a profound impact on the way LLMs learn and adapt.
You're talking about the findings related to fine-tuning.
Right.
That's where things get really interesting.
Right.
Remember how we talked about specialized training for LLMs?
Yeah, yeah.
Like sending them to grad school for a specific field?
Right, right.
Well, robust FFT takes that analogy to a whole new level.
So it's not just about giving them the right textbooks.
No.
It's about teaching them how to learn effectively, even when those textbooks are full of errors.
Precisely.
Yeah.
The study found that robust FT significantly enhanced the fine-tuning process,
Okay.
allowing LLMs to acquire specialized knowledge much more efficiently.
Wow.
Even when the training data was noisy.
That's incredible. So it's like they're not only cleaning up the learning materials, they're also giving the LLMs better study habits.
That's a great way to put it.
Okay.
And the implications of this are huge.
Yeah.
It means we can potentially train LLMs to perform highly specialized tasks like medical diagnosis or financial analysis.
Right.
Even when access to perfect data is limited.
So instead of needing massive amounts of pristine data, we can start training AI on the real world data we already have.
Exactly.
Imperfections and all.
Exactly.
That opens up a world of possibilities.
It does.
That's incredible.
And it makes you wonder, what if this is just the beginning?
Okay.
What if this is just the first step towards a future where AI can learn and adapt, not just despite the noise.
Yeah.
But because of it.
That's a tantalizing thought.
It is.
Like instead of seeing noise as an obstacle,
right,
we start to see it as a source of information.
Yeah.
A way to make AI even more robust and adaptable.
Absolutely.
But before we get too carried away with speculation, I think it's time to bring our deep dive into robust FFT to a close.
I agree. We've covered a lot of ground. From the technical details of the research,
yeah, we really have,
to the broader implications for the future of AI.
For sure.
Hopefully our listeners are walking away with a deeper understanding of not just how AI works,
right,
but also how we can make it work better.
And perhaps even a little bit of hope.
Yeah.
Robust FT is a reminder that even as AI becomes more powerful, we're still finding ways to control it, to shape it, to make it work for us, not against us.
Exactly.
But before we wrap things up completely, I do have one final thought for our listeners to ponder. We've talked a lot about how robust FFT helps AI deal with noisy data.
Right.
But what about the human side of the equation?
Yeah.
Like what about us?
Right.
The ones generating that data in the first place.
Yeah, that's a really interesting point.
Yeah.
Are you suggesting we need to get better at producing cleaner data?
Well, yeah.
Minimizing those errors and inconsistencies right from the source.
Exactly. It feels like a two-pronged approach. You know, we're making AI more tolerant of noise.
Right.
But shouldn't we also be working on improving the quality of the data we're feeding these systems?
I see what you mean.
Yeah.
It's like we're teaching AI to swim while simultaneously trying to clean up the pool.
Yeah.
Both efforts are important, and they actually reinforce each other.
And this goes beyond just like finding like technical solutions, right? It's about like encouraging people to think critically about the data they create and share.
Yeah.
Almost like fostering a culture of data literacy.
Absolutely.
Yeah.
The more we understand the impact of data quality, the better decisions we'll make, both in terms of the AI we build and how we use it.
It's a good reminder that as we venture further into this exciting age of AI, we can't just focus on the technology itself.
Right.
We need to think about the human element, the creators and users of this technology,
right,
and how we can how we can all work together to ensure a positive outcome.
Well said.
Yeah.
The future of AI isn't just about algorithms and data sets.
Yes.
It's about people.
Yeah.
It's a collaborative journey.
Absolutely.
Humans and machines working together to create a world where technology serves us well.
So to wrap things up, ROBUSTFT isn't just a technical breakthrough. It's a step towards a future where we can rely on AI to navigate the complexities of the real world, imperfections and all.
Absolutely.
But it's also a call to action for all of us to become more aware of the data we create and how it shapes the technology we depend on.
It's an exciting time to be exploring these ideas, and research like this is paving the way for a future where AI can help us solve some of the world's most challenging problems.
And on that note of optimism,
yeah,
I think it's time to conclude our deep dive into ROBUSTFT. we hope you've learned something new, and more importantly, that this has sparked some of your own thoughts and questions about the future of AI.
Absolutely.
Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.